I'm going in this video to create an actual blockchain, block after block. To do so, I will do some live coding, and we are going to create a blockchain using the proof of work protocol, meaning that we are going to actually mine the block. In order for you to understand this demo, the first thing I'm going to explain is what is a hash. And honestly, the best way to show you what a hash is, it's to show you what does a hash do. So let's go. I'm going to go on my computer and show you that. So a hash, as I said, it's a function that works on any type of file or data. So the first thing I'm going to do is to create a file. I'm going to create a file that I call test, which is simply a text file. Let me write in this little text file hello world. Okay, so now I have my file. Let me check that in my file. Yes, I have hello world. Okay, great. So now I'm going to calculate the hash of this file. Okay, here I've calculated the hash of this file. This is the result that I obtain. This sequence of letters and number is what we call the hash. It's the result of the operation of hashing the file. So now let me explain you what a hash is useful for by showing you some few more things. So hash is very interesting to verify the integrity of that file. So now let's say I modify this file, and I will modify it very little. Let's say, for instance, I only take off this exclamation mark. So this is what I've done. Let me check that I recorded it well. Okay, so I see on the computer now I have hello world, but without the exclamation mark at the end. Now let me calculate the hash. Here, what is very interesting when I look at the hash that I calculated is that I see that it's completely different actually from the first one. And I changed something very little, but I obtained a completely different hash. So now you understand potentially the very interesting characteristic of this function is that it gives something so different, thanks to randomness actually, that it's very easy to see that a file has changed. So let's imagine, for instance, you want to verify a version of the Bible. So the Bible, it's big, like it's huge. By creating this hash, it means that with this very small sequence of letters, let's say I get a file with the Bible, I calculate a hash. Let's say somebody changes one character and send me the file again. With this hash, it will be very quick to calculate again the hash of the Bible I receive and to see that it is different. And therefore, hash can be very useful to verify that something hasn't changed over time. Now, I'm going to show you that hash also have some interesting characteristics. So, one of the characteristics I really like is that actually the hash doesn't change if you change the name of the file. So let's say I change my test file and I call it test2. Now let me calculate the hash of that file. You see, here it's exactly the same as the one I had before. So with a hash, you don't really have to bother what is the name of your file. It's not taken into account to calculate the hash. Okay, so now that you understand what is a hash, we will be able to build our first blockchain. So I've created a little file to do so, and this file is available also on GitHub. So let's create our first blockchain. So first, I launch the file, of course. So I called it demo mining. And now I'm going to build the blockchain block after block. First of all, let's check what's on the blockchain. So I've created this variable that I've called demo blockchain. Okay, this variable will be the variable in which we are going to build the blockchain. Right now, it's empty. So when we build a blockchain, the first thing that we need is actually to build a first block. It's called the genesis block. So we are going to build our first block. So I've created this function to create the first block, and I've also already written a first transaction that we are going to put into this block. So I do this. Okay, so now you might be confused and don't really know what's happening on the screen. I'm going to explain you everything. But what I can tell you now is that we have started to build the blockchain. We have our first block. Okay, so in this block, what do we have? So let me erase this because I agree that it's not very clear. Let me just show you the result of this blockchain. I don't really like typing, so okay, so here is our blockchain. We have a block. It's this data as a block. In this block, what do we have? We have a hash. We have an index, which is 0 because the first block is always indexed at 0. And we have, what is very important, the list of transactions. In that case, we only have one transaction that is like this. This transaction says Isabel gave to Alex 2 demo coins. And what we also have in a block, and what I'm doing here, little notes, it's of course a blockchain just on my computer. It's not like the Bitcoin blockchain on the public network, but it has lots of similarities. So, and what we have in a block, and that's also something that we have on the Bitcoin blockchain, is a timestamp. So this block has a date, which is here. And in that case, as it is the first block, it doesn't have a link to a previous hash. The nonce, which is here, I'm going to explain you a little bit later what it is and how does it work. So we have here our first block. So now we are going to build a new block. So to build a new block, I've created a function add block to create a new block. So let's say, who wants to send demo coin? Let's say it's me again, Isabel. I want to send, let's say, 5 demo coins to Alex. So do I want to make another transaction? Let's say yes, I'm going to do another transaction. So let's say, for instance, Alex is giving 1 demo coin to Bob. Let's say it's enough. So now I've created the transactions, and based on this transaction, I'm going to create a block once I press enter, and this block will be added to the blockchain thanks to mining. Okay, the block has been created. Let me erase all this and let me show you how does the blockchain look like. Okay, so now in the blockchain you see we have 2 blocks. The first block here, index 0, and the second block here, index 1. And so the way a blockchain works, actually, you have all this data one after each other, block after block, and those blocks are linked thanks to one thing. You put the address of the previous hash in the next block. So you see here in my second block, index 1, I have the previous hash, which is exactly this hash, the hash of my first block. And that's basically how on a blockchain the blocks are linked one to each other. So now you see we are starting to build a blockchain. So let me actually create a new block. Now in my blockchain I have 3 blocks. Now I'm going to show you how does mining actually work. As I told you, here I didn't explain what is a nonce, and by explaining you how does mining work, I'm going to explain you what is a nonce. Mining is the process, and in terms when we do proof of work, I'm going to explain mining for proof of work. It's the process of finding this hash that starts with a certain number of 0 that is called the difficulty. something you might have seen is that my 3 hashes that I created here, all of them start with 30. It's normal because in my protocol that I have written, I've set up the difficulty to 3 zeros. So basically, if I change this difficulty, then the next hash that I will need to find will not require to have 3 zeros, it will require only to have 2. So now how does it work to get this hash? How is it calculated? So the way I wrote the code, and I invite those of you to look at it if they want on GitHub, to calculate this hash, I use the index, the nonce, I use the previous hash, I use the timestamp, and I use the transaction. I use all this information. But if I calculate the hash of this, how do I get 3 zeros? So the way to change the data that I use to calculate the hash to obtain different zero, in my case, I change the nonce. So, and the way I wrote the code is very simple. I start with the nonce equals to 1, then I calculate the hash. So I calculate the hash of index, nonce, previous hash, timestamp, transaction with a nonce of 1. If my hash that I obtain doesn't start with 3 zeros, then I increase my nonce to 2, and then I do the same process again, I recalculate the hash. And I do this as many times as possible until I find a hash that starts with enough zeros. So in that case, you can see that for this block, I had to calculate 4,686 nonce, basically, to go to up to 4,686 to find a hash that starts with 30. Here, I got much more lucky actually because the nonce that enabled me to obtain a hash that starts with 3 zeros was only 229. So let's look at what happens if I decrease the difficulty. If I decrease the difficulty, if I only ask 2 zeros, as some of you may imagine, my nonce will probably be smaller because I will need to have less trials in order to have a hash that starts with 2 zeros. So I'm going to do this. Okay, so let me check that the difficulty is 2 0. Okay, now I'm adding a block again. So let's say Isabelle wants to send 1 to Alex. I want to do, okay, wow. So here I see my new block. It requires to have 214 actually attempts because the first nonce is 0, I think. I probably did that. And therefore, I needed much less trials than for this one. But as it's more or less very random, it can happen that even if the difficulty is higher, I can find a solution that gives me a hash with 3 zeros at the beginning faster sometimes or as fast as with the smaller difficulty. But on average, if you do a lot of blocks, if the difficulty is lower, it will be easier to create a block. You will need less trials basically to calculate a hash that gives you a hash with this number of 0 at the beginning. A hash is actually a number. So it means that the hash value has to be under a certain value. So now we have our blockchain. Let me show you if we increase the difficulty, what happens. Let's put 40. And if you use that code at home, be careful and don't be completely foolish and don't put 10 zeros because trust me, you will not be able to, well, it will crash your computer basically. Okay, so now I add a block again. So this time maybe Alex gives 3 Timo coins to Isabelle. No more transaction. And here you will look at what happens. So the way I've done the code is that I print all the nonce every time it's calculated. So calculating a hash is very fast. So you will see the nonce appear very, very fast and cover all the screen. So let's go. Okay, so we've seen it. It was quite fast actually. Wow, we see here all those attempts, all those different nonce to obtain the hash. So here, the last nonce that I found that made me obtain a hash that starts with 4 zeros this time was 30,126. Cool, right? So, well, let's be a little bit more foolish, actually, and let's try to put the difficulty with another 0. Woo! Here you see it's taking much more time to finally find a hash that starts with 50. And basically, on the Bitcoin network, adjusting this difficulty is the way that the networks balance the fact that there are more people putting power into the network, so that we are sure that on average we will create a block every 10 minutes. Because you see, calculating those hash can translate into time that it takes to create a block. And it's actually exactly the same with the Bitcoin blockchain. One last comment now on what makes a blockchain so secure. So I'm going to show you again our blockchain that we created and explain you what makes it so secure. So as you see here, we have our blockchain. We have 1, 2, 3, 4 blocks. So as I explained earlier, in each block we see the previous hash of the previous block. And here is the key to understand why a blockchain is so secure and why it's a way to record data online so that nobody can hack it, basically. And that's how we created in the world and in history a database that nobody basically can erase or hack or alter or modify afterwards. Let's say, for instance, I want to modify the information that is in this block, the second one, called index 1. And let's say that here I would like to modify the fact that Alex sent to Bob 1 and I would like to put 0.2, for instance. If I were to do that, then what happens? It means that if I recalculate the hash of this block, as the data changed here, the hash will completely changed. And here it comes back to my explanation about the hash at the beginning. So if I do this, then the only way I can still have the block on the blockchain is to recalculate a hash that will start with enough 0 that I can then position here. But when I do that, what will happen is that I will obtain a different hash for my block. I can't have the same hash as before because I changed the data. So if I change the hash here, this means that this block is not valid anymore because this block is linked to the wrong hash. It links to the hash of the previous version of the block. So if I do this, this means that then I have to change the value here and recalculate a new hash for this block, which means that I will have to do the work and the effort again for this block. And guess what? When I do that, the problem is still the same for the next block. So as I have a new hash for this block, it means that here the previous hash is different and therefore I need again to find a new hash for this one that will satisfy the condition. So the older is information, the more difficult mathematically, technically, in terms just of work and effort, it will be to hack the data. And therefore, that's why I like saying that blockchain is like the contrary of history. Because the older is the data, the more sure you are it hasn't been modified. History basically is the opposite. Like the older is the data, the more difficult it is to be sure that it hasn't been altered over time, of course. I think this characteristic is absolutely revolutionary, and that's what makes blockchain, and in particular Bitcoin, this public database and ledger that exists, so interesting and potentially also useful for businesses. So now you know what is a blockchain and how does mining actually work, and in particular you've seen how does proof of work actually work. And now also you can understand how we built with this technology a ledger of data online that cannot be modified afterwards, which is a key characteristic of blockchain, which I believe can be also very useful for enterprise use case. If you have any question, please feel free to ask them in the comment section. I will reply to them with pleasure. And also, if some of them maybe I can't reply just by text, maybe I will even do a more detailed video on the topic if I find it useful. And don't forget to subscribe.